I'm going to be using the term for the purposes, since this was in the title that Vivek used in the slides. I'm going to use the notion of the term of digital therapeutics. But really, what we're talking about here are digital technologies that are intended to support prevention, treatment, and management of both medical and psychological conditions through behavior change and different kinds of precision treatments. So, in the context of mobile health, we're talking here squarely in the space of interventions. Some things work a little bit differently. We're talking purely about MHTI tools for observational studies, for data collection, although there is some overlap. But really, most of what I'm going to be speaking about today really has to do with different mobile health and other kinds of digital interventions. So, if you sort of broadly think about when we develop mobile health interventions, what this looks like, you can sort of think of, and this is a highly simplified and idealized sort of life cycle, but it goes from sort of conceptualizing the problem and trying to understand whether the digital technology is actually a good match for that problem, doing the initial design, and then doing optimization of these technologies, evaluation, and finally, sort of if everything pans out, we're moving into the implementation space and scaling up the deployment of these things. And clearly, the process is never this linear. There are a lot of iterations and sort of going back and forth between these steps. Often, as you start designing things, your understanding of what is happening improves, so you sort of circle back to conceptualization. Once you're doing optimization, you often change the design and so on. And so this is far more iterative than what this presents. But I think this particular way of thinking about it, of identifying these phases, is useful because each of these phases ultimately deals with a different set of design decisions that you have to make and the questions that you're trying to answer. And just as a preface for that, the way I find useful way to think about that whole process is as a design problem, right? That we're basically what we're trying to do here through the process of from the very beginning of conceptualizing the problem we're trying to solve all the way to sort of larger scale implementation. We're trying to basically iteratively create a solution that optimizes the achievement of some set of objective or intended objectives. This often has to do with sort of effectiveness of the health intervention, given the known constraints, right? And these constraints have to do with the environment in which people that we're trying to serve live and work, right? Cost constraints, time constraints, and so on. So the reason that I think of this in terms of the design of this process as a design process is because it allows us to really think of each one of these phases as having to do with certain key decisions that you're trying to make. Right at the beginning, what you're trying to understand to make the decision, the fundamental decision you try to make is whether some kind of a digital intervention is a good match for this problem in the first place, right? Or you should be doing something different, right? If you decide yes, a digital intervention makes sense, then the next set of decisions have to do with sort of what should that intervention do, right? Then, when you've made some basic decisions on that or in that phase. This optimization phase, which is what most and when the Collins' work tends to cover, really have to do with sort of thinking about what are the changes that need to be made into the intervention to make it work better, right? Again, given the constraints. And this notion of given the constraints really flows through this whole set of phases. And I think that's why I showed you that Krebs-Iban's slide, because really all of these decisions are being made in the context of the constraints that you're discovering as the project continues, right? And that you're trying to meet with the design decisions that you're making. At the level of evaluation, we think about whether this thing is actually worth rolling out in the real world, right? You're trying to give, and then finally, for the implementation and scale up, sort of the questions have to do with how we actually do that, right? How do we implement in the real world? And one way to think about all of these decisions is that they're all grounded in a certain set of questions that you're going to be trying to answer at each particular stage, right? At the stage of conceptualization, the sort of key questions have to do with what is the problem that you're actually trying to address, right? And what are the key constraints? So a lot of our formative work that we typically do to understand the community in which we're going to be working, to understand how their barriers to self-management and so on, really have to try to do with trying to understand what is the fundamental problem here that we're trying to solve, right? It could be that you're coming into the project thinking that you're trying to solve the problem of diabetes self-management, but the really fundamental problem the community is dealing with is access to sort of healthy foods, right? And so that might end up being a very different problem than the one you originally thought you were trying to solve, right? The initial design space has to do with sort of what are the key pieces of intervention functionality that are needed to address this target problem given the constraints, right? And then there are a lot of questions around optimization that have to do with sort of what components are actually needed and that need to be included in the system. How should those components be provided? When and where they could be provided? So when we talk about mobile health technologies, a big question that always comes up is the one of time, right? So what is the frequency of with which the component should be provided? Like should certain components follow other components and so on? And then at the level of evaluation, there's sort of a spectrum of questions that we ask from, is this system usable and feasible, right? Does it work under an ideal condition? And then, of course, does it work in real world conditions? And then when it comes to implementation, often when we think about implementation, we're really coming back to this notion of conceptualization again, but now at the level of sort of what does it mean to actually put this system into the real world? And so we again go back to often doing formative work to understand the barriers to implementation and thinking about what are the various kinds of implementation strategies that can be applied to bring this intervention into a fruitful life within the setting that you're trying to address. And so when you think about these kinds of questions, one thing that really becomes obvious and why I sort of went through the questions is that often in order to be able to answer those questions, you need some kind of evidence, right? But the key thing here, and this is what the rest of the talk is really about, is this notion that not all of these questions require the same rigor of evidence, nor often are they capable of having the same level of evidence, right? And so when it comes to actually thinking about methods, the way that I sort of think about this and that I want to offer as a heuristic for you is that really generating the right level of evidence has to do with picking methods as well as study settings. And we'll be coming to that back to that in the notion of whether you do it in the real world, whether you do it online, what kind of participants you use and so on, to as efficiently as possible, generate the good enough evidence that you need to make the next decision, right? Given what is at stake for that decision and given your current understanding of what processes are involved. And I will try to sort of flesh out what we mean by that, right? But this notion of good enough evidence is really fundamental to how I think about the sort of the sequence of evaluations and studies that you do when you develop mobile health interventions, where each particular type of study activity that generates evidence is really intended to create the kind of evidence that allows you to make the next set of decisions that you need to make at the level of confidence that you can sort of live with, right? Given what is at stake for that particular decision, right? What kind of differences in impact might be at stake? What kind of differences in burden might be at stake, cost, and so on. And a lot of this then requires your sort of to bring to the project your understanding of where things are, so you can actually try to decide both sort of what is at stake as well as what would count as good enough evidence. And I'll give you some examples of that. So just very briefly to make this a little bit more concrete, right? A question of sort of what are the barriers to more effective diabetes self-management for patients with type 2 diabetes in Flint is a very different kind of question than one that has to do with what kind of a visualization, for example, that you use to show progress on activity on a smartwatch. And one of the key differences here is that if you think about this very first question, it's almost impossible to get real counterfactuals for that question, right? You're basically a lot of the kind of standard methods that we use to try to address that kind of question. So most of the formative work efforts, methods that we use, interviews, CBPR, and things of that sort, are really trying to get you as a sort of good understanding of what is happening in this setting and what kind of issues people are dealing with and what are really things that are driving their health management decisions, without you being able to sort of compare that to some alternative situation that might give you a good counterexample to the setting that you're working with. And so there's no real sort of causal knowledge that is possible for this kind of question. On the other hand, but a lot is at stake, right? I mean, if you screw this up, right? If in fact the problem is access to food, but you give someone a technology that help them, make plans about when they're going to be active, right? It's just not going to work. And often you will have actually damaged the relationships that you created in that environment, right? So there's this question that a lot can be at stake, but the kind of the knowledge that is possible really has to come from this deep engagement of the researcher with the community, and doesn't allow you to have any sort of meaningful comparison in a true sense of the word, right? Well, for the second question, not a huge amount could be at stake, right? Maybe one graph will work a little bit better than another graph, but you can actually get pretty rigorous evidence for whether one kind of a graph works better than another, right? So there's some trade-offs there. And then, of course, like if you have a health system like Kaiser Permanente that Vivek and I were just discussing, right? The kind of evidence that you need to make a decision to roll out a system to the whole patient population, again, is very, very different. Then you would want some kind of a large effectiveness RCT that will really tell you that for this patient population, this is going to work, right? Because again, a lot can be at stake if patients try to use this treatment versus some other alternative. Okay, so the kinds of methodological approaches then that really you end up using really try to map to those different kinds of questions, right? So at the conceptualization stage, a lot of these things end up being really qualitative methods that are first and foremost that are being used, right? So introduce focus groups, participatory research, different kinds of literature reviews, design probes. All of these things are supposed to bring out sort of a really solid understanding of what is actually happening in this space and what a particular solution might be able to do, right? So it is very much about understanding the world, and the methods are intended to match that. And you will never be 100% sure that you got it right, but a lot of the reason we do triangulation across these various methods is to sort of increase the confidence that what you're seeing is actually what is happening. The initial design, again, often draws on sort of user-centered design and participatory design techniques, right? So all ideation, scenario-based design, personas, and things of that sort, and really are intended to translate your understanding of the world that emerged out in the conceptualization stage to some concrete functionality that you think the solution needs to have, right? And often when it comes to actually sort of the checks on this process, it's often done through things like low fidelity prototyping and early and frequent feedback from target population, where you're just basically, as you're sort of designing your first take at what the solution needs to be, you're trying to get as much as possible feedback, and it's like, is this actually in the right ballpark? Well, optimization is the stage when you often come to these more rigorous experiments of the kind that Walter was talking about this morning, right? You start running factorial experiments to try to understand which of the components from the set that you initially were considering actually needs to be included in the system, right? Micro-randomized trials to try to understand the timing of these components and their interactions with other components that are provided in time, and so on, right? One of the things that can sometimes happen in optimization experiments, especially if you're dealing with populations that are, if you're trying to address a problem in a population that is actually hard to reach, is sometimes you might make perfect sense to you to leverage proxy users. If there is a particular kind of question where another set of users that is more easily accessible can provide meaningful responses, right? That if it has to do with, for example, how human beings, perception, and where you don't think that perception, how visual perception works in patients with particular, let's say, rare bone disease is different from a general population, you might be able to get some feedback on, for example, things like feedback graphs from a broader population, even though the final solution is actually intended to support a very specific patient population, right? So thinking about, again, sort of what do I understand about what is happening for this particular design decision, and sort of how can I get data, evidence for it effectively, given my constraints, becomes really sort of key in optimization. And that's a lot of the examples that I'll give you have that flavor. And then finally, when it comes to evaluation, it's sort of a whole set of sort of standard kind of behavioral science studies that we normally think about, from proof of concept studies that are intended to show feasibility and acceptability, to pilots, right, that show you that you can actually run trials, and then of course the efficacy and effectiveness RCTs. And then, as I noted before, when it comes to implementation, often this ends up looking very similar to repeating this process once again, but now on the implementation side. So to unearthing barriers, doing barrier prioritization, modeling of how different implementation strategies are actually addressing different barriers, and so on. But again, the idea here is to try to understand what is a set of implementation strategies that need to be used in order to maximize the likelihood that this intervention can be effectively implemented in the real world. So that's kind of the sort of broad overview of both the phases, as well as the kinds of questions and the methods that might address those questions. And so what I want to do in the rest of the talk is actually give you some very concrete examples of what this might look like, and that I'm hoping will make this a little bit more digestible and concrete. So the first project I want to talk about is this this project on smartwatch displays that a PhD student that works with Mark Newman and me did a couple of years ago. And what the goal here was really trying to understand how the design of different kinds of feedback that can be provided on a smartwatch to give people feedback on their progress on activity goals is going to influence the accuracy of the feedback interpretation, right? And so why does this matter? Because partly if you design the feedback poorly, right, it's possible that feedback is not going to be as effective as a feedback that is better matched to address this issue. But at the same time, there's this question that potentially there could be some burden issues as well, right? So that if the feedback is confusing, if participants are not able to see that they're actually progressing, they might get frustrated and disengage from the intervention, right? So, but both of these, if you sort of think about it, are in terms of how much is at stake. There is some stuff at stake, but it's not massively heavy. But there's still sort of, so you still have to make a decision. If you're going to have an intervention that has smartwatch based feedback, you need to sort of make a decision on how you're going to do this, right? And the reason that I'm saying that not potentially a huge deal is at stake is that if you sort of think about how this goal feedback on a smartwatch works, right, it could actually work through multiple mechanisms, right? Only some of which really depend on the person being able to accurately to see the discrepancy between the feedback and their actually goal state, right? So some of the stuff that the goal feedback does is just provide self-monitoring, right? It just gives you some sense of the behavior that you've been doing, right? It also just makes you more aware that you are pursuing an activity goal, right? And then finally, there's this notion that if you think of goal setting as a control loop, right, that there's a discrepancy between where you're currently and where you're trying to be, right? And so we know from the literature that both for self-monitoring and for salience, the accuracy doesn't actually matter all that much, right? You can still get change in behavior by doing self-monitoring, even if the self-monitoring is not particularly accurate, right? But discrepancy is really important if you think of this as a control loop, right? That goals are really intended to help you reduce that discrepancy between where you're currently and where the goal state is. And so that's the place where having crappy feedback could actually hurt the intervention, right? And so there is something at stake here, but there are other channels where goal feedback can also work. And so given that level of sort of what is at stake, how would you study this question? So the way that Yushuan did this is that she actually looked at the literature and decided there are three design dimensions that could potentially be really interesting in sort of making designing a smartwatch-based feedback, right? One has to do with salience, right? So how easily seen and recognized the feedback is, right? And so often this is operationalized either as size, and that's how we did it in our study, also to whether this is in the foreground or background of the display, right? And the trade-off here is that you're dealing with a small display, so that space is at a premium. And if you make something bigger than it needs to be, then you have less time, you less space to put, the time which the watch is supposed to show and other things, right? The other one is granularity, right? How granular the feedback is in relation to what you're trying to, the progress that you're trying to present, right? And so the trade-off here is that smaller increments are actually much harder to notice, right? So if you think about something like Apple Watch, right, that has that continuous ring to show progress, it's like, it's really hard to tell if you've walked another, 100 steps or 500 steps that changed, right? It's very granular display, and it kind of ends up filling out really, really smoothly. And it's only after much larger chunks that you actually see a change in a clear way, right? And then there has been a fair bit of work in human-computer interaction on using stylized representation. So using things like images, for example, to display feedback. And some of the usefulness of that is that you're actually able to make these representations privacy preserving, right, as well as sort of aesthetically pleasing, right? So, but they're also unfamiliar, and so they might require learning. So what you shouldn't want to do is actually see how these different dimensions actually affect whether a person is able to accurately understand the feedback on the watch. And so what she did is she actually created a whole bunch of, in this particular case, I think it's 32 varieties of a feedback display. And these are the two that use different combinations of these 3 dimensions, right? And so we have three factors, right? Salience, granularity, and stylization. And for each one of those factors, so that gives us 8 conditions if you're doing a standard factorial experiment, the way that Walter described it this morning, right? And so she actually doubled that so we have some redundancy around, so to make sure that anything that we're seeing would not be just an idiosyncratic property of one particular representation. And so she did a bunch of these kinds of designs, and then ran a web experiment, right? She's actually running an experiment on Mechanical Turk to study smartwatches, right? Where we actually were able to recruit over 200 Mechanical Turkers. And then they were using this we set this up as a game of memory, and Yushan wrote a memory game that plays on the web, where people were basically told that they're expecting a meeting over Zoom, and while they're waiting for the meeting, they ended up playing a memory game. And then to just check that it's time for the meeting, they were supposed to sort of hit a space bar, which would display a smartwatch for 5 seconds. And after the smartwatch disappears, the game would sort of interrupt, and the person would be asked to both report what is the display time as well as the goal progress in that particular on that we're showing on the watch. And so each participant completed 3 tasks for different levels of goal progress, and the primary outcome here was an absolute error in judgment of progress. And then they also, at the end of the study, did a bunch of usability, comprehension, and other subjective measures, right? Questionnaire. And so this is kind of what it looked like. And the idea here was that when a smartwatch display would show up, it was kind of the size that you would see a watch from about 2 feet, which is typically how far our wrist is when we look at the time, right? And so what did she find? She found that stylization negatively impacted the interpretation of accuracy, but it wasn't a very large error. So it was sort of an extra 2.6% over the standard average error for the whole study. Low granularity hurt accuracy as well, but this error was even less big. And so for both of these things, the errors were small enough that we didn't think that they would preclude the level of stylization, the use of stylization and granularity that made sense for other design purposes, right? But what was interesting is that none of the people in the study actually preferred stylized representations in terms of comprehension, complexity, and attention. They all thought that they were actually much harder to interpret and harder to use than the more traditional graphs that were being used. And so I want to step back and sort of talk a little bit about why I showed you this, right? One key question here was really this question of sort of how would you design a smartwatch display, given that there are many different options, right? And so given what is at stake, right? It's not the level of evidence here that is needed to make this design decision is not huge, right? But you need something, right? Otherwise, you're just kind of making it up, right? And given that this is really a question about visual perception, you could actually get some initial evidence for this question from an analog setting like a web experiment. I think this is actually really interesting, right? Even though when we normally think about some things like wearables, we think about that they're used in the messiness of the real world. But for this particular process, which really has to do with how people interpret feedback, right? We could convince ourselves that actually this is mostly a visual perception issue, and that we could study that visual perception in a laboratory, just same way that if you do physiological psychology, you can do these kinds of tests in the laboratory, right? But furthermore, and this is really important, right? So what that actually provided us are with the ideal conditions for looking at these processes. And we thought that if one of these particular dimensions was really bad in the ideal conditions, that is likely going to be even worse once you actually get all of the messiness that comes with the real world. So like people being distracted and trying to track the time while they're running to the next meeting and so on, right? And finally, doing this in the real world would be infeasible for a number of reasons. One is actually to require a lot of resources, both development resources, because you would need to do all of these kinds of variations of the smartwatch. The sample size would be huge, right? And so on. And and there would be even some methodological issues here that you wouldn't actually be able to tell when someone is glancing at the watch with high level of accuracy, which is what you would need to be able to do to give someone an EMA to answer these questions, right? So the level of complexity and resources that would be needed to do this in the real world would be completely mismatched with the level of evidence that is actually needed to make a decision on how to design a smartwatch display, given that not a huge amount is at stake, right? So for a couple of $1,000, running a web experiment could actually give us a fully powered study that provided some initial evidence on this question. And so sort of that kind of matching of evidence to the question is sort of really important, I think, to do this style of work, both rigorously and efficiently in terms of resources. Okay, so another project that we're to demonstrate some of this is hard steps. And I know that Walter talked about this a little bit, about hard steps a little bit in the first presentation, but I'm going to be actually focusing on a different intervention component than Walter was talking about. So, as Walter told you, right, the purpose of hard steps was to help sedentary adults with increasing physical activity, right? And we wanted to also pilot micro-randomized trial methods as part of that. And we had these two components, right? One was the contextually aware activity suggestions, which is a component that Walter talked about. But the other component was this planning component that was really trying to help people get some longer bouts of activity by planning the day in advance, right? So in the evening, planning for the next day, when, where, and how they would be active on the next day. This is the notion of implementation of intentions from social psychology. And the real question here was like, how should this planning be actually designed, right? And so we were particularly interested in two versions of this. One was to basically do an electronic version of how implementation intentions are typically done in social psych, which is you ask someone to write a plan, right? So you give them sort of instructions of at what level of specificity the plan needs to be made, and then you just sort of have them write a plan, right? But given that a lot of our lives are routinized, right? We are also really interested in seeing, could you just give people a list of plans that they had previously made, and they could just pick a plan that made sense for the next day, right? To decrease the burden of making plans, right? And so what is at stake here is that if writing plans on the phone each night is burdensome, right? So there was some concern there that participants might get disengaged over time, right? But also there was not any clarity about whether choosing from a list actually works as well, because there was no literature on this prior to our study. And if we just decided to go that way and we ended up creating an intervention that is completely ineffective, right? That is not good, right? So what we ended up doing is actually we micro-randomized planning in addition to those activity suggestions in the 6-week study of hard steps. And the way that planning was randomized is that people, half of the time, so every second night on average, they would not be asked to plan. And then other times they would be asked to plan with 25% probability, whether they got, either to write a new plan in a text box or choose a plan from another list, right? From a list. And the proximal outcome in this case was the step count on the following day, right? So we wanted to see to what extent actually planning allowed people to actually get more activity on the following day. And so when we looked at planning sort of marginalizing across both types of planning, there was nothing really interesting going on there. There was no difference between planning and not planning. But when we separated them out, it turned out that open-ended planning, so writing a new plan in a text box, added about 500 steps per day over not planning, but there was no effect at all for choosing from a list, right? So this is starting to get a little bit more interesting, right? But then when we actually look at the moderation of planning effects, this is where things get really interesting. For one thing, at least in our population, no planning actually seemed to work on weekends. Our participants just did not like planning on weekends, and it didn't matter what kind of planning we gave them, it just didn't do anything on weekends, right? But on weekdays, open-ended planning, if we give them open-ended planning, added almost 900 steps a day, right? While there was no effect again from choosing from a list. So we're getting some additional evidence that choosing from a list doesn't seem to do anything. But what is also interesting, and this is for those of you who have done mobile health studies before, is that there was no significant interaction with the day in the study. So basically, that for this particular component, the effect remained constant over time, over the course of the 6 weeks, right? Which for a lot of the components that we see in mobile health interventions, you end up having a decrease in effectiveness. So this is pretty interesting, right? So the takeaways here are that only open-ended planning seems to work to increase the activity the next day. But and that effect seems to remain stable for over the 6 weeks. So there's no decay in potency, and that at least for this particular population, sort of providing planning prompts on weekends was ineffective. That didn't do anything. Now, what do we learn from this, right? In terms of methodological issues, one is that if you sort of think about what we did here, we had both a relatively short study and a small study, like 6 weeks, 40 people, right? And it could still provide useful data both for what kind of planning to use and when to provide it, right? And so there was actually a fair bit that we can learn even from a very small study, this is a very small optimization study. The other thing is that unlike that previous project that I just told you about, both of the key questions here, they're both in terms of the efficacy to increase next day step count and burden over time, has to be studied in situ, right? You can't do this in a web experiment because the actual efficacy, the behavioral efficacy, you cannot demonstrate in a web experiment, as well as the sort of people need time to see whether they're getting tired of you or not. Finally, there's also a really interesting thing here that might actually inform how we think about the processes that are underlying these interventions, which is that the difference in efficacy here might actually have to do with to what extent people were paying attention when they were engaged in planning, right? So when you have to write a new plan, you have to pay some attention, right? Well, when picking from a list is very quick, people will typically spend one or 2 seconds on that operation. And it seems that it's possible that was just not enough time for the plans to get encoded in memory sufficiently to actually make it effective. And then, as you saw from the stuff that Walter presented this morning, so what you're starting to see is that sort of these optimization studies can actually get really useful data across multiple components in a really efficient way. So in this particular case, we had 2 components about which we learned quite a bit about how those components should work by running a single study. And now I'll give you a sort of a third version, a variation on that, of sort of how you can pack multiple questions into a single study. And this is a project that I did with my colleagues Dori Rosenberg and David Arthurburn at Kaiser Permanente, Washington, and where we basically were trying to support weight loss maintenance in patients who underwent bariatric surgery, right? And we basically, and the idea here was to develop a scalable intervention package that can be added to the standard clinical care with minimal sort of burden on the health system and the providers, right? And to make this as broadly reach to make this intervention as broad reached as possible. And so part of the project goal is very much to assess the standard feasibility of this intervention package. And we had several things that were going on in this intervention. One was an activity tracker. This was just a Fitbit charge that off-the-shelf tracker. The same thing for Withing's digital scale. So we had some commercial pieces that people could just, that the system could just ship to patients. And then we augmented these interventions with some custom text messages. And we had several things. One is an adaptive daily step goal that help people sort of become more active over time. We had the same kind of activity suggestions that we used in hard steps, but now delivered through text messaging. We had different kinds of reminders, both the reminders to track food intake as well as weekly weigh-ins. And then there were sort of tailored bariatric diet tips that were customized to how far from the surgery each person was. So they would get some diet tips that were related to the week, to this particular week that they were in, depending on how long ago they had their bariatric surgery. So the questions that we wanted to answer here were very much in this sort of optimization and early evaluation space, right? So we wanted to see, first of all, whether these activity suggestions actually do anything when we send them via text messages, right, versus notifications. And the main difference here is that when hard steps, we had an app actually running on a phone, so we could get information about the person's location, which would allow us to get both the sort of we would know whether they were at home or at work or at some other place, as well as we could get accurate weather forecast. Well, when you send something to just a text message, you don't get any of that information, right? We wanted to know whether the text messaging reminders for food tracking actually increase adherence to self-monitoring. But then we also had this design question around adaptive step goals and how we should design the adaptive step goals. And in particular, we were sort of interested in whether this notion of variability was important to incorporate into the step goals. In terms of the goals, and this is what I'm going to just briefly talk about, the state of the science is this notion of a 60th percentile goal, which was developed by Mark Adams, who is at Arizona State, over a course of a number of projects, where basically he found that if you sort of track people's activity, and you take the last 10 days of their step data, and then for the 11th day you just pick the 6th highest step count, you will end up with this really gentle curve of slowly increasing step goals that will shape a person up to 10,000 steps a day, right? And so the adjustment here happens pretty slowly, right? Which on the plus side is very gentle, right? People can sort of slowly move their activity level up, which is really important, especially for a population with bariatric surgery patients. But on the other hand, how quickly that goal adjusts is pretty slow. And there's also some questions here about how motivating these goals are, because they really change very little from day to day. So one day you get a goal that is maybe 200 steps more than the goal you got the day before. And so based on some of the work that Eric Keckler has done in his students, where they actually sort of change the goal quite a bit from day to day, which they try to run an experiment to understand sort of to what extent how ambitious the goal was affected goal attainment. We were interested in whether actually sort of increasing the variability in the goal would make a difference. And so what we did is we ran a 4-month study with 51 bariatric patients from Kaiser Permanente, and we did sort of all the standard pre-post measures that you do in a feasibility study. But then we embedded both a factorial experiment to study adaptive goals, as well as a micro-randomized trial to study activity suggestions and diet tracking reminders. And in particular for this factorial experiment, we basically varied whether people got a 60th percentile goal or a variable goal, right? So that changed from day to day between 50th, 70th, 90th, and 120th percentile goal. And then as the other factor, whether people got rest days. People who, participants who were randomized not to get rest days would get a step goal every day, while those who got rest days would every once in a while with 1/7 probability they would basically not receive a goal for that day, so they didn't have to worry about trying to reach a goal. And so What we found on the feasibility side is that we actually got pretty good results. About 1,800 step increase between the start of the study and end of the study in terms of, as well as a pretty large reduction in sedentary time, 41 minutes per day between the start of the study and the end of the study, right? So really promising results that sort of mean that this kind of project is actually worth continuing forward with. Right? Not enough data to actually fill this out to all of Kaiser Permanente, but definitely enough to say there is something happening here. This is worth spending additional resources on. But what was interesting on the adaptive goals is that the more variable goals ended up resulting in sort of marginally significant increase, statistically marginally significant, but substantial increase in terms of the effect size of over 1,000 more steps per day. And this is averaging across all 4 months, right? People who had more variable goals walked on average about 1,000 steps more per day than those people who got the 60th percentile goal. There was also sort of slight decrease in performance for people who got the rest days, but that was not significant statistically. So what do we get from this in terms of methodologies? One is what you see in this particular study is that you can run a study that addresses question across multiple phases of the digital therapeutics lifecycle, right? In this particular case, we had both optimization questions that are around the goals, that were around those activity suggestions, that were around how to design the actual self-monitoring reminders, as well as initial evaluation questions. In this particular case, sort of proof of concept, feasibility kinds of questions. Right. So you can combine methods into a single study across multiple things, right? So what we had here is both pre-post comparisons. We had a factorial experiment and we had micro-randomized trial all thrown into the same study. And then the key part here, I think for our purposes is this notion that deciding if evidence is good enough often will require you to triangulate across different evidence sources, right? So if we look at sort of what we are seeing for the adaptive goals here, the effect size is actually quite large, over 1,000 steps per day for just this one manipulation, the form of the goal that people get. But it's marginally significant, right? But what we get from interviews is that people really like variable goals, right? They never knew what to expect. Some days they would get an ambitious goal and they would try hard to get it. Other times they felt like they were getting a goal that gave them a break. And so that actually was a really nice an additional sort of source of evidence that matches what Eric found in his study, that the variability seems to actually be quite valuable in terms of engagement in its own right? And so in terms of sort of making a design decision, how do you develop adaptive step goals across those 3 pieces of information? We have enough, I think, evidence here that in the next iteration of this project, I would probably use variable goals because they seem to work better both in terms of people's subjective perceptions as well as that they seem to at least we have some initial evidence that they work better in terms of actual impact on activity. All right, and just quickly to summarize, and then we can have some discussion. So one thing that I want you to take away from this is that viewing the studies as evidence generation for design decisions can be really useful, right? So you're not just trying to evaluate project. You can run studies that are intended to help you make decisions about what you need to do next. And that helps you both clarify what level of evidence is needed, as well as it allows you to efficiently combine questions into a single study that can advance the design project in multiple places. So if you think about this benefit project, it was both sort of, does this whole thing, is it worth continuing with going forward, right? Feasibility question, as well as a number of optimization questions for individual components that were contained in the package, right? What rigor of evidence you get from a study might be perfectly sufficient for making one decision and completely insufficient for another decision. So in the case of benefit, the feasibility results are good enough to say, there is something here. We should probably apply for an R1 to sort of support the further development of this system and then do a proper efficacy evaluation. While it's not strong enough to actually bypass that next step and say, we built a cool system, go KP, deploy this with, to all of your thousands of bariatric patients. It's just not same evidence, but depending on what decision you're trying to make, it's going to be either be sufficient or insufficient for that decision. And then finally, this notion of what is at stake in this decision is really fundamental to my mind, right? Because it really provides guidance on whether something is worth studying at all, right? It might be that you sort of think about the decision you need to make. And when you start thinking about like, well, what would happen if I got this wrong, right? You decide, well, nothing bad. And you can just make the decision based on your best sort of design intuitions or the literature that is currently available and move on with your life, right? While for other things, that question of what is at stake will really decide what's the level of evidence that you want to collect. So in the case of that smartwatch display study, you're able to actually potentially run experiments that are much cheaper, much faster to do than what you would be typically inclined to do if you just sort of think that the only real sort of research that we need to do is running these technologies in the real world, in the messiness of people's daily lives, right? And so that is, I think, one of the sort of most useful heuristics I have found to really try to think very carefully about what kind of work needs to be done to move the project forward in this DTX lifecycle. All right, I'm going to stop there, and I'm happy to take any questions and hear whether any of this was actually useful. Thank you so much. I'll turn this off so I can see you.
Thank you, Pedja.
Thoughts, questions, or was this?
I think there are some who work with HCI. Don't know if Ravi's around.
Ravi's around. I see him. Yes.
Oh, you do.
Sorry. I initially had a question during the previous talk. It was essentially how do we gather design evidence and feasibility before we actually do the full study. And your talk definitely touched upon many parts of it. How do we do the initial feasibility study? What is the earlier evidence? And I think the 5 stages that you provided are very well mapping on the design thinking approach.
Yeah, and I think that's exactly right. So the piece that only alluded to here that I'm happy to talk to you more about has to do with sort of trying to articulate what is the causal process that would differ based on whether you make the design decision in one way versus another, right? And I have some examples actually even for these projects that I just showed, where so you can sort of think about, let's say in the case of that planning intervention, right? So you can sort of think about the UI aspect of that intervention, whether you're just giving people a text box or you're giving them a list, as really activating some additional causal pathways. Causal pathways having to do with sort of activation, in this particular case, of attention. You're forcing certain amount of attention to be paid by having someone write a plan, while they can just sort of skip through the interaction very quickly in the other case. That actually ends up being part of how we, if you think about how planning works, the need for attention is actually there. Like if you look at the psychophysiological literature on planning, it seems like attention is actually pretty fundamental to making planning work correctly, to encode those plans in a way that allow for this automated execution of the task down the line. And so to some of these design decisions end up needing to be framed in terms of what else gets activated in terms of the causal pathways if you design things in one way or versus another way, right? And then you can sort of try to think about like what's the study that would give us a sense of whether that those hypotheses are panning out. Like, and it could very well be that a lot of that stuff can actually be done in the lab before you push stuff into the world. Does that answer at least some of what you were getting at, Ravi?
Sorry, definitely. Yeah, thank you. And I'll definitely be reaching out separately to just connect and go over more of that. Thank you.
Jill?
Yeah, hi. Thanks so much for this presentation. It was super helpful. I'm Jinsol. I am a clinician with an interest in design thinking, but my question is with regards to theory of saturation, like how much of that is accepted in the community in terms of testing ideas using participatory design, and are there some best practice strategies to do those PD research early on to be able to kind of predict the next feasibility study, like you're talking about with like the web experiments? And then the other question I had was around the level of evidence that you were mentioning. And I think like some of these interventions, I feel like, and I'm just speaking from naivety here, but like a simple text message intervention, things like that, like they might be able to be deployed in a cost conscious manner. So do we really need these large scale studies to prove its effectiveness, or can we, like from like with regards to like the practicality of implementing some of these approaches within these big industry or healthcare partners, like do you find that we need to get to that like R01 funded study to vet that this intervention needs to be deployed, or can we just do that study that you had mentioned, and then is that good enough? Like what's the reality of implementation?
So I'll answer the second question first, because I think it really will depend on how you're sort of, again, how you're thinking of what's at stake here, right? And so one thing that could be at stake is the relationship between the health system and the patients, right? So if you're giving them, you do an early study that does not potentially assess the level of burden that is actually involved at the right level, and you just deploy to a large number of patients, and a whole bunch of people get really frustrated and disengaged, and then you might have damaged the relationship that is needed to deploy anything with those patients next, right? And so it's not just effectiveness. Like if you could say, well, even if it doesn't work too terribly well, if it's, since there's a lot to reach, it might be still worth trying, right? There's also, especially in the cases of where there, in an institution like Kaiser Permanente, where there's actually this strong relationship between the organization and its members, right? Giving them stuff that is going to frustrate them can actually be quite costly, regardless in terms of the sort of whether they continue to use Kaiser insurance, whether they continue to volunteer for other projects that Kaiser is wanting to do, regardless of whether the intervention is actually effective for whatever it is that you're trying to do, right? And so I think partly you sort of have to figure out really what is there. Financially cheap is just one form of cost. There are all kinds of other costs that you will need to sort of take into account and figure out, am I okay risking not seeing sort of the effects on those other areas of cost? Or it might be that your small study actually covered those, right? If you ran a study with 50 people and the study was long enough, you deployed text messages for 6 months, and people actually were fine with the frequency. They were fine with that might be good enough to address some of those other potential sources of cost that you can say, yeah, we don't necessarily need a large effectiveness trial. We'll just go ahead and try this, right? And so again, what I'm not arguing is that you have to go through that whole pipeline all the way to a massive effectiveness RCT, right? But what I'm saying is that you need to be thoughtful about what all the various sources of cost might be, and be able to make sure that whatever studies you end up doing are assessing those sufficiently so that you feel comfortable making the decision to skip the next step if you won't decide to skip it. Now, in terms of saturation, when you say theory of saturation, do you mean just the fact that in qualitative research sort of you sort of keep gathering evidence until you're not seeing much new stuff come up? Is that the saturation in that sense, or what?
Yeah, exactly. Like when you're doing more of these qualitative research approaches to test, an idea, assuming you understand the problem, are there, do you find that when you do those qualitative interviews and you reach a theory of saturation and you do the next feasibility study, that there is kind of this predictive relationship with?
For some things, yes, right. So for example, when we get even, if you run one study with 15, 20 people, where for example, let's say this concept study with planning, right? When people told us that getting planning every couple of days was too often, anything that we did later that uses the same frequency pretty much confirmed that. Like that, it was just that for a lot of people, that frequency was just too high, right? And so in some of the subsequent work, we try to make the frequency, we asked people to plan once a week, but we gave them a chance, they basically allowed them to plan at will at other times during the week if they wanted to do that. But so in sometimes you actually do get the things that emerge from these smaller studies actually carry on just fine further out. For other things, like if the context changes sufficiently, things change, right? So the things that we were hearing prior to COVID and things that we started hearing once after the lockdown were very different in a lot of respects, right? And that had to do with just that sort of people's reactions are very much grounded in their lived experience, and that lived experience is going, dropping off the kids to school and then going to work, and all of the structural activity that is involved in going to the grocery store and getting the bus and so on, and all of that goes away. So things that they were perceiving in one way in terms of support, right, for physical activity, start getting perceived very differently once you're locked at home. So I think it really, insofar as the context remains relatively invariant, right? Absolutely, the results of qualitative research can carry on just fine.
Pedja, we'll take one more question. I thought Olga had a early question, and after that we'll move to Susan. Yep. Olga?
Yeah, hi. Thanks,
Hey.
Pedja. That was a great talk. Yeah, I was just wondering a little bit of maybe coming back to kind of the early stuff that you were talking about, the whole life cycle, and sort of thinking a little bit more about kind of implementation, because I guess there are maybe different models to consider here in terms of if something is maybe sort of co-designed within the service to begin with, do we even need implementation at the end? So I was just really curious about your thoughts here, and maybe if you have some examples of apps that have maybe been kind of implemented at broader scale.
So I'm happy to talk more, but the very quick answer is that yes, that often you still need full-on implementation, even if it was designed within the system. That because often the actual design work is done with relatively small set of clinicians in sort of select clinics, and when you try to roll it out to across the whole system, all kinds of things come up that have to be dealt with. And so it's at least, I'm not a card-carrying implementation scientist, although I've been pretending to be one more and more in the recent years. But in all my work with Kaiser and their quality improvement, it looks like doing some level of implementation where it seems to be necessary for things that are emerging from inside the organization.